Hello. Hi, everyone. How are you today?
Hello, Maud.
Hey.
Hello, Vicky and Lai.
So, it's great to be with you today. Very excited. It's our first collaboration between Dublin and Paris.
Yeah.
Yeah,
Oh,
great
Vicky, you
to
are
meet
on
you.
mute. Hi.
Yeah, thanks. Yeah, it's great to collaborate with PyLadies Paris this evening. Thank you again. Yeah, this is I really enjoy kind of collaborations like this. So we're gonna cross kind of pollinate speakers and communities and stuff. So welcome everyone who's on the YouTube channel for PyLadies Paris. So I will leave the introductions to I think Maria and Maud.
Thanks, Vicky. It was really great collaborating with you as well. Hopefully, we can repeat that in the future. And thanks to our speakers, we have two very exciting talks. I hope you are looking forward to them as much as I do. So it's our first Paris Dublin event. Let's see how that goes. So we can go to the next slide. So we are four organizers from different parts of Europe. So it's Lei, you can wave Lei from Dublin, and I am Maria from Paris. Vicky is also from Dublin, and Maud, she's
Hello.
also with me in Paris. So we organized this event for you. But let's not stop on this slide too long. And we just want to ask you to be kind and respectful as always to each other. You are very much welcome to chat on our YouTube channels. So both Dublin and Paris are streaming at the moment. And you can ask any questions as you like. You can discuss anything on those channels, but please be respectful. Let's make together a nice atmosphere. And if you want to find out more about our PyLadies Code of Conduct, here you can see the link to the Code of Conduct. And in case there are any problems, just don't hesitate to reach out. So also, please say hello. Maybe say your name or whatever you like on the chats. And share some appreciation for our speakers. They took some time to prepare these talks, and we are really happy to have them here with us. And also, don't hesitate to ask any questions, even if you think the question is stupid. It's not stupid. Maybe something was not clear. Probably, if you have these questions, others will be also very happy to hear the answer. So really, any questions are welcomed, as long as they are respectful. And you can also reach us on Twitter. So just go to the next slide. Here you can see our Twitters. So as for the next slide, just a very quick schedule. So now we have some quick announcements. I will first say them about for Paris, and then I will pass it to Vicky, who will give her announcements for Dublin. And this will not last very long, don't worry. Very soon after Qishan, I hope I'm pronouncing your name correctly, will talk about his experience as a researcher. And soon afterwards, Maria Camila will continue telling us about unraveling the mysteries of the universe with Python. And if you have any questions, you can ask them anytime. Don't worry, and we'll have a question and answer session also at the end of the talks. Okay, and so for our PyLadies Paris, here are different channels how you can find us. So first is Slack. You can just join PyLadies Slack and then find our Paris chapter, which is City Paris. We always try to be active as possible. We have waves, but please come and say hello. We also give some tweets on our Twitter account, Meetup. Probably if you are from Paris and you signed up for this Meetup, you already know this page. And we also try to give some slides, if possible, after the talks on our GitHub account. Okay, and so you can always reach us by our email, paris@pyladies.com. And we are always looking for speakers. So please reach out to us if you have any Python related topic you would like to talk about. We are very happy to hear from you. Also, if you would like to host one of our events on site, please reach out. Or you have any suggestions. We always, preparing the events takes some time. And we are always happy to hear from you, whatever is good or whatever is bad, so we can improve and continue to be better for the future. And I would really like to take this opportunity also to thank all of you for being with us tonight. As I said, it always takes time to prepare these events. So for us, the reward is that you're really with here and that you participate. It's the biggest thanks for us. So thank you. Okay, and so we have the next meetup. This time it will be on site, so we will meet in the bar in Paris. We are still not revealing the name of the bar, but it's coming shortly. But you can already sign up if you would like to for our meetup. So the reason why we decided to do it is because in the park, when we met 2 months ago, it was really nice to chat with you and meet you in person. I think you also enjoyed it, so we thought we will repeat it this time in a bit different setting. So thanks again, and I will pass it to Vicky.
Thanks, Maria. So yes, we're PyLadies Dublin. Again, another person on the team is Mick, my husband. So you can find so the Twitter handles for all of us is there on screen for Lay, me, aka YK, and Mick. Just a few announcements. I normally announce kind of diversity events that are happening around Ireland. And WITS this evening. So after this meetup, you can, if you register for them, you can just head straight into their science panel if you're a student and you hear about careers in science. But they also, and people who don't know who WITS are, WITS is Women in Technology Science Ireland. They're not-for-profit members organization who's been around for over 30 years here in Ireland. And so they're doing a series of a kind of student career series. And aside from that, they also do coffee mornings. So you can see that's the next one on October 21st. And then, yeah, there's another, there's an engineering panel as well on the October 26th. There's a startup event for for entrepreneurs from Awaken Hub, so you can check that out as well. Don't worry, I will share this afterwards, after the event, so all the links and all the information for those who are interested after the event. Other events of note here in Ireland is, of course, the monthly Python Ireland meetup. They have theirs, and the next one is November 10th, and you can find the information on python.ie. They're also on Meetup. The Dublin Data Science Meetup group, they're having a workshop on October 18th. And the first in-person meetup that I know of here in Dublin so far is Codu Community. They're having a web developer meetup. So for anyone who's doing Flask or Django or whatnot, you can, if you are comfortable enough to drop in, they're having it. Harvey and Ash here in Dublin is hosting their meetup. Our next PyLadies event is on November 16th. And it will be our last meetup of 2021. We don't normally host meetups in December. We have 2 talks. The second one is going to be confirmed once I finalize details. The other one is using Python to bring physical games to the internet by Jeffrey Rowe, who is from a director at Hackerspace here in Dublin, as well as one of the the organizers in Dublin Maker, who so I used to work with as Baker advocate prior last couple of years. So that would be very interesting, because that project is kind of showing you how you can use Python with electronics. And this is a project that he showed that he will be showing at the Maker Fair in Rome, the next one. So if you're interested in how else you can use Python with, especially with electronics, and you're curious about it, come join the talk. And that will be live streamed as well, and information is on Meetup. And of course, don't forget to, as I know I don't do this at the end of the talk, but no, but I might as well do this here. Don't forget to like and subscribe our YouTube channel, not just PyLadies Dublin, but PyLadies Paris as well. And all support, kind of, we really appreciate that. And you can find us on Twitter. And if you want, we're also on LinkedIn. And without further ado, don't forget to pop your questions on live chat. So hello to everyone there watching us on the Parisian and the Irish, or the Dublin YouTube live right now. And do introduce yourselves to each other, ask organizers questions, ask any questions you have for speakers, and myself, Maria and Leigh, we will gather those questions and we will share them at the Q&A after the talks. And so yes. Okay. Sorry, I just saw another message there. Please. Oh. So I suppose this one is for the organizers in PyLadies Paris. Can you send the Slack and Discord link?
Yes, so we have a Slack. We can send the link. By the way, Dublin is also on the Slack group, so we'll send you the link.
You will send the link there, and I'll post it on our live chat here in Dublin as well, or we will post it on the live chat in Dublin as well. So what?
Do you have Discord?
No, I don't have Discord either. I think if people want to do, you go to Discord. I think there's a big Python Discord that server. If you haven't already, I'll dig it up and I'll share it later. And probably if I get a chance on the chat here. But I think there's a general PyLadies Slack. And then PyLadies Dublin doesn't have Slack because I just have too many Slack groups. But yeah, we'll share whatever information we have in the previous slides on the chat here. But yeah, we're not in Discord either. So let's get on with our first speaker. So I would like to introduce you to Qishan Yang for Insight, right, in DCU. And you'll be talking about being a research survivor. So take it away, Qishan.
So I'll just let you unmute yourself, and then, yeah, great.
Sorry. So I can share my screen and can you see my screen now?
Yes.
Okay, great. So, hello everyone, and firstly, thank you for attending my presentation. Just a brief introduce myself, and I'm Qishan Yang. Currently working in Dublin City University in the WAKI project as a data scientist. So today's topic is about research survivor. Actually, my original topic was the Python survived my life, but it's so obviously so straightforward. So I changed it because you don't need to listen to me and you follow the topic title, and you know what's going on with my presentation. So we're gonna have 5 parts And the first one is I give you a little bit of my background, and then my PhD research and postdoc research, followed by the counter job I'm doing, and in the future, probably my direction or the research direction, I don't know. So let's go to the introduction first. Yeah, I think I have been staying in the IT area for more than 10 years now. So I took my bachelor degree in China and a master in University College Dublin in Ireland. So both of my major is computer science, and after this I continued my education in Dublin City University. My research, my PhD research was about data warehouse architecture, modeling, investigation, and evaluation. So if the company just want to build up a data warehouse, though probably they need to choose a best option for the architecture. So that's the topic I was doing a lot of research on that part. And after this, I joined a project named the Gatekeeper as a postdoc researcher. In this project is quite interesting, and we are using deep learning model to analyze the gait data. I'll give you the details in that part. And the so 1 year later, I joined a startup, which is the Walkie project based in DC, in Dublin City University, and this is my counter job. So in summary, I think I have been using Python for many years. I think it around 6 years now in my research, and I mentioned that earlier that I couldn't survive without Python. So and oops, sorry. Oh yeah. Yeah, as everybody knows, then Python is quite popular, and there's no doubt about that. If you search the Python and for the popular programming language rankings, though Python normally goes to the top one, top at least top three programming language in different purposes. So, but that's the main reason that why I use it. Because during my PhD, I was using Java and to analyze big data. For example, if I'm familiar with the Hadoop or some other like HBase, though they based on the Java. So and also I use the R if you're interested in the statistics. So probably you're familiar with R program and language. But finally, I chose Python because it doesn't have much limitation that I mentioned, like Java and R. So you can use Python to analyze data, to build a backend of the website, and also collect the database and retrieve data as well from the database. And the last one, but not the least, that it can run and train and run the deep learning models. So that's the main reason, and also machine learning model as well. That's the main reason I choose I choose the Python as the main language in my PhD research. So I summarize my research in 4 steps. That's the normal way then for the PhD research, I think. Firstly, we need to do the literature review. I did several systematic literature reviews and to understand what's going on with this field, and then at the same time collect data. After this, I designed the several program flows to collect my data, to analyze my collected data, and then get a raw result. These are some of the raw results and I got from my data. And then after this, I designed my methodology and the framework to, as a tool, finally provide a company or people who are interested in this area, and at least that can help them to make some decision. So after this, as I mentioned, I joined a project in the Gatekeeper. Though we collect videos who walked from point A to point B, and then we use the deep learning model to analyze the each video frame by frame to get the skeleton of the body. We also call it the key points of the body. After this, we use the different types of the models and the normal ways to finally generate around 25 features for each walk. So, for example, the distance, the speed, the stride, and the number of steps, and some other things. And then we will send out the data to the hospitals. Then they have other methodology to diagnose some disease. For example, the diabetes or injury, something like that. So at the same time, I have another project to understand what's going on with the key point of the body, and they used it to develop a mobile game. So they use Unity and AR Foundation to like educate the children how to do some activities. So, and they're quite happy because they have the right reason to playing games. So, and currently I'm working in a startup. We help the HRs and the manager to make some decision and authority. At first, we need to give them the analyzer result and help them to make some decision and better manage the staff and the company as well. So what's going on with this? So we are building a system in the AWS environment, and we use the different types of deep learning models to analyze the data, for example, and the feedback messages and also the surveys. For example, and this one, if I got the message from employees, so we probably need to understand and what's the sentiment level for this messages. So if I send it back to the backend, and then we'll get the result for the sentiment level. This very positive. So just imagine if you have like hundreds of thousands of feedback messages and from your clients or from your staff. So probably it's a little bit hard to analyze and classify them manually. Probably you're going to take 2 or 3 days to get a final classification. But for this one, probably we only needed like 10 seconds to get the result. And also we did some other data analysis by using some deep learning model as well. If you are familiar with the SageMaker or the Lambda function, I think it's easy to understand what's going on with this the whole system. Of course, I use the Python. I use the Python to handle the queries, and also use Python to run the deep learning model in the SageMaker. Yeah, and in the future, actually, surrounded by the big data. So I was thinking everybody had the same situation that I had. so but my journey is a little bit different, because then at the very beginning I learned how to collect and manage data, and then I was trying to understand the human physical activities, and then to trying to understand from the outside of the body to the inside of the body. And so I found my just and summarize my research or my career journey like this. So maybe in the future I'll do some like research or investigation on the human beings from scratch. So that's but who knows? Nobody knows on that. So and but one thing I just want to mention that I'm quite sure that I'm gonna use Python in the future for my further research or my further career. Yeah, that's pretty much everything I just want to share with you guys. Hope you enjoy it. And just to mention again, yeah, Python helped me a lot. So yeah, that's why I choose Python, because I was using a different programming language like C# and JavaScript, of course, then Node.js as well. But most of the time I prefer Python, but sometimes then we need to use multiple programming language to solve the different problem. Yeah, but again, Python is my main programming language. Then I use in the daily life. Yeah, that's it. Thanks, guys.
Thanks, Qishan, for your talk. That was very interesting. I think there's a comment from Jeffrey saying
Stop
that
sharing it. Okay, yeah.
You can stop
Okay.
sharing. Yeah.
Yeah.
It was I think it was a comment from Jeffrey saying it was interesting to see research being using industry level tools. So I suppose there's a general question actually, since you deal with data as well, don't you? So someone has been asking questions like a question you might be able to suggest. Is there any book and site for data science with Python for absolute beginner? From so I know there's like lots and lots of, but from your perspective, do you have any suggestions?
You mean that any online resources that we can learn Python? Or
Yeah, so someone who's kind of new into who's a beginner, is there any kind of for data science with Python from your experience? What would you suggest? I know we have a lot of suggestions, so I'll pass it to you and see what you suggest.
Yeah, good question. Because then, but I need to mention that Python is the one of the easiest programming language that we currently have. So, for example, like if you know Haskell, if you know say C++, probably Python is easy to learn. So, I haven't taken any modules when I was learning Python. So I normally, if I just make your hands dirty. So just trying to programming, and if you have some like issues or problem blocking you, so maybe just Google it. I think it is loads of online resources you can learn from it. So if you have some other backgrounds of programming language in terms of other programming language, so I think it's quite easier for you to learn Python. So don't worry about it. So, but you need to believe yourself. You can learn Python better than other programming language because it's easy.
So for the person who asked about this question, as I said, there is a whole lot. Probably it's just, the question is asked because there's an overwhelming amount of resources out there. So when I have a collaborative pad, which I normally do during my announcements, I'll send it out after the meetup, and right at the bottom, after all the announcements and stuff, at the bottom there's a whole bunch of resources I've been collecting over the years, and people have been suggesting sites to go to and things like that. So we have some beginners stuff there. We have some after you do your 101, what you do afterwards. So for those who are curious and getting into it, check that list. For those who have experienced this process and found some other good resources, please let me know, and I'll add to that list as well. So that'll be much appreciated, because there's just too many resources out there. So be nice to get some from the community, you know. Oh, another question. If I learn data science, is it necessary to learn deep learning too?
I don't think so, because the data science or data scientist, I think it's a very broad field. So for some guys, I know some of my friends, so they don't know too much about like deep learning, because then they normally use then like data warehouse or the ETL or machine learning models. So but it's really depend on your job. So if you find a job and then they are quite interested in the deep learning, probably you need to learn. But I think now the learning curve is more better than before. I mean, more smooth than before. If you want try to learn the deep learning with Python, I think it's easier than before, I have to say. Yeah.
All right. There was a question. Someone is typing a question, but it got deleted again. I'll wait another second. But in the meantime, we'll just hold on for another 20 seconds just in case they're typing a question. But oh yeah, what kind of statistics? What kind of statistics? Well, I think this person was saying like, what you need to know in statistics to learn if you're doing science. Again, it's like a very broad.
Yeah.
So I suppose if there's any pointers, I suppose I think this is something where I'll be building up a list of resources. So maybe it's something, if you can't think of at the top of your head, you can also share with me afterwards, and I'll post it up as well. We'll be keeping a list of all the questions asked. So if do you have an answer for
I think just a brief suggestion or my personal experience though. If you just want to for IT part, if you want to be a quant, maybe you need to know more better and know deeper. I mean, in terms of the statistic. But for me, I think I didn't go deeper because then I don't need it in my daily work and in my previous research. So know the basic things like how to use R and how to get my result. That's it. So that's a lot my direction. Sorry about this.
Yeah, I suppose it really, as you say before, it really depends on the project, or depends on your job, or what's required and what's needed because data science is such a huge area as well. So, okay, I think it's time for our next talk. So thank you again, Qishan, for speaking this evening and joining us and your time. So I'll head over to Maud here and PyLadies Paris, and they'll take over from now.
Hi there. So it's great to be here again, and I'm very lucky because I get to announce our next speaker. So our next speaker is Maria, and Maria is an astrophysicist. She will let us a bit more. She will let us know what this means exactly, and share some experience that she has in this field. And as before, I'd like to invite everyone to feel free to ask questions in the chat. Do like Sarah did just before. She said she really liked the talk. She found that Qishan's work was really impressive. And so I think that's really great to hear for all of the speakers and also for all of the organizers who are always happy, to invite and receive people here with us. So yeah, keep it like this. And now I'm gonna let the microphone to Maria, and when you're ready, you can start.
Thank you, Maud. Hello, everyone. So, yeah, today I named my talk Unraveling the Mysteries of the Universe with Python. So, what we're going to do is I'll try to give you a short overview of how we can apply Python in astronomy. I'll go through some of the tech stack that is most used. And the most fun part is we're going to work through some of the real world and really impactful examples of its applications. So, just to start really quickly, my name is Maria, and I love the universe and computers. Like that's the the best sentence I could find to describe my interest. I'm currently a software engineer, but as Matt said before this, I have a background in physics and I specialize in astronomical simulations. Um, so that's why I'm talking about it today. Well, random fact: I really like to sculpt ceramics on my spare time. Okay, so let's get right into the subject. So the first question is why? Why would we like to mix astrophysics with computation? Something that we usually relate a lot with observations, telescopes, but why is the role that computation is playing more and more in this field? So there's tons of reasons. I chose these main three because I think they're very different to other fields of science. So the first one is that apart from some specific areas of astronomy, in the most part, we don't have laboratories. We cannot play around like other sciences or other areas of physics do. So it's really it's not like we can say, okay, let's move the sun a little bit, or let's give this velocity to this planet to see what happens. So that barrier that we have to test our hypotheses computation can help. Another thing is, well, the scales, right? Even if we were able to push the sun, we're really, really tiny compared to it. So how would we do it? How would we handle something when our Earth is really, really small relative to the major bodies, celestial bodies that we study? And the third time is the times of evolution, right? It's interesting to view how a system evolves or to analyze how a system evolves. I don't know, like the solar system, for example, if we keep our same example of the sun, after tons of years, not only like what would be our lifetime. So these three main reasons make it really appealing to make use of computers and to try to model what we think will happen in systems that can perform it really, really fast. So I try to summarize it a bit in a phrase, is that why do we want to do computational astrophysics? Well, because we can be the masters of our own universe or different universes, because at least from my own experience and what I did, it was definitely just simulating what we saw and like being able to control every single bit of your universe. So, okay, what can be done? Again, tons of examples here. I'll just try to like abstract it in these main four. So we've been talking about simulations, meaning you start from some initial state and you put some rules to it, like a game, and then you just let it evolve. So you see what happened. You simulate some behavior. We can also do data analysis, because this is a branch. I mean, general science really just outputs data, but in astronomy there's a lot. So we can do all of the data analysis that actually there have been PyLadies talks about that science. So all of these things could apply here. We could do plots and so many plots because that's the language of science. Apart from English and math, I think people communicate through plots all the time. So it's very important to have more visualization tools than the typical ones. And well, we still have telescopes, we still have experimental data that's coming. So how do we process and handle all of these observations that we're doing in a more automated way? Again, much more things, but I'll just touch on those four. So now we would ask, okay, why Python? There's so many languages. Like, why do we choose it? So again, I display the what for me are the most important. So first is it is very accepted in the scientific community each time more and more. Like a lot of scientists, both senior and junior and entering in the career, are embracing Python as a tool. So it's now very easy to cross communicate across teams. Like if you have a collaboration with another, it's very likely that you both are going to know Python. So it's again, it's becoming like more of a common language among everyone. We can also do a lot of fast prototyping. So sometimes in science, you just want to test really quick hypothesis, because if you test it wrong right away, then you can just move to another one and another one and try to find your path really quicker. So if you have fast prototype, you have fast results, that let you advance faster whatever research you're doing. The third one is that there's tons of specialized libraries. So anyone that is fairly interesting in a particular domain can create its own library, or can also contribute to it, or can use it. So it's very easy to find a niche of the topic you're interested in. And well, since a lot of people are using it, it's much easier to find more support for the library you're interested in. And the final one is that there is a great community. It's very easy to learn. I think this is something that's not only for astronomy, but for all Python in general. And one interesting thing is that it's free, because astronomy has a history of using other languages like IDL or Fortran that are specialized software for for this, and they're not free. You have to pay. So there's not always like budget like in companies for doing research with paid software. So it's very nice that this is open for everyone. So now I'll try to walk through a little bit of the tech stack. It's I think you're going to recognize it. So in terms of libraries, well, there are particular ones. Like, for example, you have AstroPy, that is for making data analysis of observational data. So it's very, very dedicated to astronomy. It handles units and things like that. But if you see, we also have NumPy, SciPy, Pandas, and Matplotlib. These are like four of the core libraries of data science. So it's something that I think most people can relate to if they're on this field. On the side of more mathematical sides, we have SymPy for symbolic calculation, or we have MC for Monte Carlo analysis. So of course, there are much more. As I said, there's very specialized libraries, but this could be a really good place to start. I'm trying to go next. Yes. But we don't only have libraries. We also have some frameworks that are much more specific. So here I'm just highlighting one that's called AMUSE, that is an astrophysical multi-purpose software environment that, because a lot of people, for example, I'm going to take one of the subjects that it touches on is stellar evolution. A lot of people do stellar simulation. So someone already prefabricated a base ground from which everyone can start on. So you don't need to create all of your architecture, all of your modeling for your problem. You can literally import stars or import a planet, import a body, and play around and mix around them. So this particular framework also has hydrodynamics, gravitational dynamics, and radiative transfer. So you could combine and say, okay, I'm going to import a star that can share mass with another star and that rotate around. So there's already very, very specific frameworks. There's also toolkits that do not only apply to astronomy again. For example, there's YT, that is an open source Python package for analyzing and visualizing volumetric data. So a lot of people in seismology also use it. So now we're moving more to visualization. There's also some other suites like Blender or AstroBlend, that is like a particular case, so that we can not only obtain data and analyze it, but we can also see it. So in this case, you can see how they blended some galaxies colliding. And well, those are some highlights of the tech stack that we have. So now we're gonna move into the fun part, and it's the actual example. So what have people done with Python that is really inviting? So the first one is one example of Amuse, the framework that I was talking to you about. So this is a visual representation of a simulation of a star cluster. So the idea was to see how, from an initial condition, you could start seeing how they all interacted with each other and moved around. So it includes, as I was telling you, because there's already a built-in framework, you can play with more complicated things. So you can add effects like losing mass, or seeing like the more interaction than just the gravitational one. This video is rendered as you would see it from the Hubble Space Telescope, and it's snapping a picture every 31,000 years. So that's why you see it moving very fast. And I don't know, particularly, I love seeing things like this, how you're literally playing with stars. So this is the first one. This one is also with Amuse. It's not as rendered as the previous one, but it's really interesting because this team was trying to prove so that there is, in our solar system, there is a planet called Sedna, and it's around 3 times farther than Neptune. And there is a theory, because the location is so far, the electricity, its characteristics are odd for being part of our system and to adhere to the theory that we think of planet formation. There's a theory to say that it was actually captured, so it was not initially formed in our solar system, but it was from another. Oh, I thought I played the video, but I didn't. Here it is. So the scientists theorized that it was actually a consequence from a collision, no, a pass by among our galaxy. Our solar system, and within that interaction, the sun was so powerful in its gravitation that it was able to take and stole one planet of another system. So they had the theory and they simulated it, and they were able to corroborate that the end state of their simulation match the actual observations and the actual description. So this is, I didn't mention this before, but this is a little bit how simulations work. You have some hypotheses, you have some rules of evolution, and you see if after the time you want, they can match. So they did, which is also very, very interesting. So this is in terms of simulation. So I'm going to move a little bit now in terms of hardware, of telescopes and things we use to observe. There is a project called DESI. It stands for Dark Energy Spectroscopic Instrument. And it has a goal that is to measure the dark energy in the universe. In order to do so, it's going to obtain a lot of spectra of different galaxies and quasars, and it's trying to do this three-dimensional map of the nearby universe. So the way it works, we're not entering that much in the technical details, but when you want to take an observation, when you want to take one set. Oh wait, before I forgot to say this. Sorry. When you see the tech stack of DESI and how this telescope is built, because it's taking so many observations, it's automatic. So within their infrastructure and within their pipelines, if you see, there is a whole set of external dependencies that I presented to you before. It's NumPy, AstroPy, SciPy. Well, there's others. But it's very, very based on all of these open source libraries that we use in Python all the time. So like Python is literally helping us unravel the mysteries of our universe in this case. now I move into the part that I was saying before. When historically, when you wanted to take a picture of the sky and you're interested in some particular bodies, what you do is you say, okay, I want the sky at this time, and these will be the locations of the stars that I'm interested, let's say. So the astronomer, well, the technicians of the telescope used to create a really big wood circle plate, and they will punch holes in the particular locations of the objects they wanted to observe at that time. And then someone had to put in all of those different holes that were matching that moment, the optical fibers to take the spectrum of all of these bodies. Well, of course, this takes time, and afterwards you end up with a piece of wood that you cannot use any longer because the sky is going to change. So the idea here was, this is a sub project of that pipeline, was, okay, how can we use Python to automate this process? And in this case, instead, they replaced the person putting all of the fiber optics, but by some hardware that can spin and can rotate on its own center, but also like move around. And the idea is that, how do you program these to be able to locate the sky and locate the fiber optic? So now you don't need like a physical thing, well, sorry, a wooden thing to hold your fibers to take the images, the spectra. You can do it automatically by rotating mechanical things, but all of this, again, programmed in Python. So that is automatic. Now we're almost there. We have two more examples. I don't know if you heard this. This was very hyped a while ago about the gravitational waves. So there is LIGO, that is an laser interferometer gravitational wave observatory, look on Earth, and the goal was to, well, open the field of gravitational waves by their detection, because they were something that we predicted but we haven't seen already. So they were able to discover a gravitational wave. Just as a small summary of how it kind of works, there's two very long perpendicular tubes that go on each direction, and the idea is, while the gravitational wave passes through Earth, you shoot some lasers at each side, and they return, and because there's going to be a slight compression in one of the directions, you can see the delta and detect the wave. Really, really big overview. But then what's interesting is that they released all of their data to the public. Well, at least some of it, but a significant part. So you could, and they, apart from the data, they also released a lot of Jupyter notebooks that, well, use Python to analyze it and to show you how they do their processes. So they're like removing this filter of unknown and showing you how you can, well, interpret it and play around with it. So one thing that's really interesting is that with some Python libraries for audio and also for plotting, I'll show you the plotting after, you can see or hear the gravitational wave. So I really like this example because you can listen to it. After you code all of it, I'm going to play it here. What you would... Okay, I stopped because I was going to cover this sound. I'll play one more time just in case it was not well heard. I didn't play it. Okay, so and this is the visualization. If you see a plot of frequency and time, so you can see things that 10 years ago we didn't even know that existed, thanks to Python. And that I really found amusing. So this is more on the side of that analysis. The last example that I'm going to show today is the newest one of all, which is very nice. It's called the LSST. It's a project that stands for Legacy Survey of Space and Time. It's going to be a telescope located 8.4 meter telescope located in an observatory in Chile, Vera C. Rubin Observatory. And the idea is to build a robust astronomical data set of the deep universe. So this thing is going to make a 10-year survey of the sky, and the idea is to take all of the sky in the lapse of all of those 10 years. The telescope is really big. It's 8.4 meters, the mirror, and it's the size of a Volkswagen, kind of. It also has a really potent camera, 33,200 megapixels. So if I'm going to move to the next one, if you want to do a map of the entire sky, like patching every single part of a sphere of what we see during the course of 30 years, that's going to be a lot of data. How much? Well, it's going to generate 20 terabytes of data every single night over here. Again, 10 years. So what I want to show you here is that you need, well, you definitely need to automate this. And now, since you're playing around with terabytes of data, you're going to need big data techniques and a lot of infrastructure that supports this telescope. And all of their pipelines they did using Python. So you can see all of their Python models in this website and how they connected their whole architecture on top of the language. So just before closing up, just wanted to say that all of the examples that I wanted to display were to show that our discoveries right now and the state of science is very, very well, not of all science, but at least of what a very significant part of it, and in particular of astrophysics, is very very linked now with computation in all of the, from simulations to instrumentation and everything in between. So it speaks up for the power of the language and of the power of computing in general. So I want to thank you, everyone. I'll stop here. And if you have any questions, I'll be happy to take them.
Thank you. Thank you very much, Maria. It was really a great presentation. We had a lot of people commenting, saying they were really interested in what you presented. And we also have some questions, so I'm going to read a few questions for you. And one question is, how much computing power do you need to create an experiment like the one from Amuse that you showed?
Okay, I showed two from Amuse. I'll go back. I would have to see the specifics of each of them. So there is like the star cluster simulation, and there is the collision of the two systems, solar systems. So I worked closely with this team for 3 months, and even though we did have an internal cluster that we could run things into, there were also a lot of computations that we were able to do on our own personal computers, laptops. So it depends on the level of complexity that you want to adhere to this. But something cool about this framework is that, well, they know that it can get complicated very quickly and that you might need a lot of computational power. So they have a lot of settings to parallelize it. So itself, you don't need to configure it. Itself will be able to run whatever you can in different cores or in different processors. So you can optimize your time, but yeah, I don't want to answer it depends, but it does depends on the complexity. I don't know for these two specific cases, but I think if you just want to start playing with it, they have a lot of examples on their website that will definitely run and very nice ones, by the way. So for how much you want to complicate it, you will need more, but you can get a fairly good amount of playtime, playground with a normal laptop.
Okay, thank you. And a question: is it easy for beginners to use the framework Amuse?
So, well, of course, it depends on, again, on your level of comfort with technical topics, but I would argue that it is. It is. They have a lot of documentation. I mean, it is a project. I didn't went through a lot through the story, but it's a project that was born in the University of Leiden in the Netherlands, and there is an active team there. Then, and they since the beginning, and they have engineers as well of the project. They are very, very active and do so many research with it, so they're very approachable as well. There is a community that you can reach. There are books about it, with a lot of exercise and like textbook exercises that you can play. And most of the things in the end are not that complex. Like if you are struggling, or if you're interested in learning the theory, it's also not that at certain level is not that complicated. So I think it's beginner friendly. I would ask for help if I needed, like reach out to the people around it. But if you're interested, I would recommend you to go for it. It's very well made.
Okay. And one last question. How much Python made your job easy for you, and how?
Well, because I was always on the computational astrophysics side, it was my world. More than making it easy, it was what I was doing. But if I focus specifically on the language itself, it's mostly the things that I said at the beginning. It has a great community. Everything that I was wondering of that didn't work for me, I was able to search online and to find answers, if not to reach out. Um, and I think just the language itself is very friendly. So I was able to ramp up on it. Well, more than ramp up on it, Python was my first programming language, so I have a close relationship with it. Um, but in comparison to others that I learned afterwards, I yeah, I think it is just very nice. I don't know. It made it a lot easier.
Okay, thank you. So that's really great, and thank you. I want to thank everyone in the comments who really said some very nice things. And I'm gonna put online again the other organizers, and so we can say a little goodbye for everyone who has their camera turned on. And yeah, it was really, really great. Great topic. I don't know if Qishan is still with us. And we had like a lot of comments from Olga, from Sohail, from Sarah, from a lot of people, both in Dublin and in Paris, who says thank you to both of our speakers today. So yeah, I think that's really great.
Thank you for being here.
I have one question actually. How do people like? I suppose there was a lot of questions about beginning into data science. I say Jupyter Notebook would be a great one to get on to install and try out, and you can just start experimenting, typing code, and getting your data and playing around with it. And it's not just for experimenting. People use it for lecturing, facilitating workshops, doing everything, like a whole sandbox. So I say for so how if a lot of the stuff you want to try out, instead of trying to install everything, trying to figure out, check out Jupyter Notebook. It's still called Jupyter Notebook, right? I know it's the names have been changing over the years, but it seems to be like a big game changer for people, for low barrier to entry, to try to from basic Python right up to doing stuff in data science, I suppose. And I suppose do you recommend it? I certainly do, and I'm not a data person, but I definitely would for people playing around with it anyway.
The wiki, you're right, and I use Jupyter, as well, within your work,
So I suppose we're supposed to close up, right? So I like to, if there's no questions coming through, thank you to everyone who joined us this evening on both in on the Parisian YouTube channel and our YouTube channel. And thank you to Maud and Maria from PyLadies Paris again. It was great to collaborate with you. Thanks to both our speakers, Qishan and Maria, for interesting talks this evening. And it definitely got very exciting anyway. Seeing all the different examples, it really makes a difference in how Python is used in the real world in various different projects. And big thanks, obviously, to Leigh as well, who's always there helping out in the background. Very quiet, but you do a lot of work and helping me out. And big, huge thanks. And but yes, as I said, go to Meetup to find out information about both PyLadies Paris and PyLadies Dublin's November meetups. Follow us. We're on Twitter. We have agreed we are all on Twitter. We're not on Discord. PyLadies Paris is on Slack, but there is a generic PyLadies Slack channel. I've posted it. Leigh posted it on a live chat there, and I've posted the Discord for the general Python server as well. So it's quite active. So I'd like to thank everyone again for your time this evening, and I will see you next month. And I will leave Maud to close us out then.
Yeah.
Thanks everyone again. Have a good
Thank
evening.
you. Bye.
Thank you.